look at our unit. This is our Transformations, Constructions, and SOL Review unit. So it's kind of like a mini unit and then SOL Review. So So today we are learning about rotations and dilations. Last night for homework you did some translations and reflections. For most of you this is probably familiar, that you did a little bit of it back in middle school. Does anyone remember what a dilation is?
When you make it bigger.
Good. Yep, it gets bigger and smaller. I take it back. Today's actually just rotations. Dilations next class. That's okay. So today we're doing rotations, dilations in the next class. So the next class is lines of symmetry and dilations. And you'll notice that now our homework has a few different components to it. So we have a normal homework, which pertains to what we just learned about. So tonight you have homework on rotations. And then you start having SOL review, because this is our SOL review unit as well. And so for each night, you'll have a little bit of May Madness homework to do and a little bit of the SOL review packet to do. So those are the two things that you picked up right there. The May Madness is just having you recall certain concepts like midpoint formula, distance formula, ways to prove it's a parallelogram, how do we know if it's parallel lines, things like that. So just a couple things from there. And then your SOL review packet, this is an actual released SOL from, I think they released it in 2015. Which means it was a previous test, so a test prior to that they actually gave. So what I've done is I've gone through and I've written out which problems specifically to do that will pertain to units 1 through 3. So tonight for homework you'll be doing rotations and then basically reviewing material from units 1 through 3 with your SOL review May Madness. And then next class we will go over our homework. And then we will take an SOL review quiz number 1. And you'll notice we have those almost each day. This is supposed to say review quiz number 3 and 4, so if you would write that on right here. And 4. Yep,
Whoa.
and 4. So these are little SOL review quizzes, usually about 10 questions, mostly multiple choice, sometimes a short answer within there. And they're geared towards the topics that we did for homework the night before. Now note that your homework is not a completely extensive review of all of units 1, 2, and 3, but it's just supposed to be a refresher of it. Now, of course, Unit 1, which was talking about the basics of geometry, we've been using throughout the year, but you might need to refresh memory things like skew lines. Unit 2 was our logic and reasoning. Unit 3 was our parallel and perpendicular lines, and we've used parallel lines a lot, but you might just need to refresh memory with it. So you'll notice we have almost daily SOL review quizzes, and then we have our transformations and constructions quest. So this is a large quiz, small quest. I think it's 50 points. I can't remember if it's in the quiz category or the test category. I have to look back and see. But so this is about 50 points, and there aren't retakes on it because it is just a quest. This is over transformations and constructions. So this is when constructions will finally appear on an actual assessment for you. And we'll continue to review constructions and stingers, and on our review day, we'll do a refresher in class as well.
What would a construction like even do? Yeah, how would a question for
Draw the angle bisector using constructions. Draw a line perpendicular through P to line K using constructions. So you'll actually use the compass on your test.
Whoa.
Alright, transformations and constructions are on the SOL, so that's gearing up for the SOL as well. And within our SOL packet, I want to talk about that for a moment. So on your SOL packet, like I said, this is a previously released SOL. And when it says numbers 1 through 16, 1925, if you look in the bottom right-hand corner, it says like 1 of 45. So it has sample A, sample B, 1 of 45. That 1 of 45 is question 1. And then the next page has 2 of 45. That's question 2. 3 of 45, question 3. So those are the page numbers, if you would, are actually the questions. Does that make sense for that? So what I want to talk about with our SOL review is that the SOL review pack that you have is an actual SOL they've given before, which is great, but they've made some changes since then. So you'll see some technology enhanced questions on there where it asks you to like drag the box, you'll just circle the box. This year they've added some new standards. It hasn't changed much for us for geometry, it's the types of questions they're asking. They haven't really released information about, they haven't really given us examples of that. So I'm giving you what I know to the best of my ability. Okay, so this is the most recently released SOL, but know that it is a few years old, but it's the only thing that the state of Virginia has given us. So You'll notice at the end of this SWAL/transformations unit, we do have a practice SWAL test. This is supposed to mimic an SWAL test, but again, it's mimicking what the SWAL test used to be like because it's different now. This is actually going to be all multiple choice, whereas the ones that you have now have those technology enhanced questions, okay? So although when you get this test back, and I will tell you what your percentage would have yielded on the SWAL, it won't be it'll be a predictor, but it's going to be a rough predictor because they use a completely different scale now. Back when they had just multiple choice questions, like 90% was a 500. But now the questions vary in difficulty and not everyone gets the same questions. So I could have two people that get the same number of questions right and get two completely different scores because it depends on which questions you got right. So I will tell you that based upon the old scale, what does your grade translate to on SOL score? But just know that's a rough prediction with the new SOL because it's before they used to release and say this percentage equaled this score, this percentage equaled this score. But now it's not that way anymore. And we have no way of knowing because the questions are varying in difficulty. Based upon what type of question you get right determines your score. Okay, so you'll get a rough prediction, but it's a rough prediction. Okay. Questions with that?
Do you know what day the SWAL will probably be?
Yeah, so for us, our SWAL is probably May 23rd. Let me double check. Don't write it down. You can write a probably, but I don't have official words. Okay, probably the 23rd. We don't have the exact. We don't know exactly which classes are on that day, but geometry is on the 23rd, but also possibly I think 24th. So I think most of us are on this day, but they haven't told us which teachers.
Okay.
So probably it is each day. Black.
Oh,
Okay, so most like this is their date, but when I get the official word, then I'll have you write on the paper. So you can write down approximately that, but don't think that that's
wait, so after SOL, can we
No, you still keep going to school the rest of the day. Yes. Okay.
I have a migraine.
So again, each day you'll have kind of a few components to your homework. The homework over the new topic we've learned, and then SOL review in terms of May Madness and the SOL review packet. Well, we are gearing up toward our transformation and constructions quest on the 8th. And then we will have one more day of review, and then our practice SOL test. We'll go over our practice SOL test, and then we start into our ellipses unit. So once we get close to that, then we'll take a look at our assignment sheet for ellipses and the rest of the year. But for right now, we are at SOL transformations. Questions with this?
Is the SOL an actual SOL, or is it the MCAT where you can't go back and?
You mean the SOL that you're taking this year?
Yeah.
I believe you are still able to go back and forth between questions, but I think that is coming. But I believe this year it is still you can go back and forth between questions. But there has been talk about that where they don't let you go back. As far as I know, they haven't changed that.
Like, what if you see portion and gives the answer?
Okay. Other questions with this? Okay. All right. So go ahead and tuck this away, and let's take a look at our homework. Yeah, little SOL review quizzes.
So they're all online.
Oh, that's like speaking this.
I wish. Right, so for your homework, you're supposed to read a couple sections in the textbook and then complete this. Again, hopefully this was familiar to you. Most of it. Some of it might have been new. Who can explain to me what an isometry is?
Isometry is,
What did you say? They're congruent, good. So we have to have two figures that are congruent. They can be rotated, they can be flipped, but they must be congruent, so they must be the same shape and same size. So that's why we have 1, 3, 4 are in isometry, because our free image, that's our starting shape, and our image, our final shape, are congruent, it's just it's been rotated or turned in some which way. 2, it's different sizes, so it's not congruent shapes, so not excluded. Okay.
Still this.
Do we have questions on 1 through 4? Yes.
On the text, will it be clear if it's like, it's not the same, because on number 3, I was like, I couldn't tell if they were different or not.
If it looks pretty the same, then it's gonna be. If you like number 2 words, like that's definitely a
Yeah.
size. Yeah. All right, so 7, 8, and 17, and then 9, 10. So for these, you had to, for 7, 8, and 17, you had to draw the new picture. For 9 and 10, you wrote the rule. Now, the rule we're just thinking in terms of shifting left, right, up, down, and then what does that mean for x's? So for number 7, it says x minus 1. What does that mean that I'm doing to my shape?
Going left one.
Good, I'm going left 1. Good. And then y plus 4, what am I doing there?
Down.
Up.
No,
Up.
up.
Good, going up 4. Good. So you're really just applying that to your picture, and note that our image, so the final shape, has our little primes. So you should have A prime, B prime, C prime. That's what indicates to me that is your final shape, your image, and not the pre-image. The pre-image is your starting, image is your final there. Now also too, just notation for you. Here we've used parentheses. Depending on textbooks, sometimes they use these little kind of carets. It's the exact same thing, it's just another way of writing it. It's because this is used to represent a vector, and later on in math, should you choose to take the classes that deals with vectors, that's the notation that's used. So these are the same thing, just different notation, but they mean the same.
What was that? 9?
Alright, do we have questions on these?
Just send it that one. I used to have.
This is already moved so far. Not even.
Let's go. I'm getting it right.
Well, it was that far when I came this morning. It's just with each period. And when we like have future, it doesn't move back. It does. Alright, do we have questions on 7 through 10 and 17?
Wait.
Alright, and then we've got Washington, D.C. and there's another transformation.
For this one, could we have it in like the quarter?
Yeah, so let's see. North, south, east, west. Did you say south?
Let's go.
Did you say that?
Yes.
Awesome. When they specifically talk about directions, you usually want to give back directions. But if it asks for, this is what we call a transformation rule or translation rule, that's that notation.
Got that.
All right, questions on 11 or 13?
Reason because.
And then on the back side here, I think you can sneak in all of those. And notice again when it says, like for 15 says write a translation rule, this is a rule where you say the point x, y maps to what new point.
You actually have right.
Alright, do we have questions on 14, 15, or 1 through 6?
I didn't get number 1 through 6.
1 through 6. So 1 through 6, you have to just draw every scenario for it. So number 1, it says we're going across the x-axis. Here is my x-axis. And it says the point A. The point A is 2 above, so I'm going to go 2 below. So that would be the point to -2. And then, like, for example, let's say 4. What is the line x equal to -1? What type of line is that?
Box.
Good. So we've got bucks, we've got point. X is vertical, so it's a vertical line at -1. So then I want to take D, that is 1 to the left, so I want to go 1 to the right. That's fine. Here's D, it's 1 away on the left, so I'm going to go 1 away on the right. And that gave me the point 0, 2. Okay, so again, with reflections, the idea is that we want to have that same distance away. Okay. Let's go take a look at our next one. This is where you had to draw it on separate paper, perhaps those of you that followed instructions. I think we're going to skim those next two. Is that a hand stretch?
Oh yeah, did it right.
So 11 and 12, you're just simply reflecting across the line. We're not on the coordinate plane. Right, you're just reflecting across the line.
What if your drawings aren't good? Like, what if you have to like, throw those on a test and your drawing is just
Well, it should be pretty close to it.
my name? You just like half of it.
Yay, I will cut it to you just. Alright, do we have questions on 7 through 12? Alright. So then now 25 and 26. I actually want you to talk with your shoulder partner about what you did for 25 and 26. Oh wait, let me see shoulder partners. Jocelyn just going to spend with Canadian So Kyle and Zach together, and then I teach mine. Maybe sure to work with Patrick and Zoe, and I bet Matt sure to work with Alex and Dominic. I have Brian and Cole together, so I'm trying Adam together. You're gonna pair up with Michelle and Anna. So Michelle and Anna, you're gonna work with Andrew as well. So we have quite a few groups in there. Are you telling me it's not the
That is correct. There we go.
I don't know how it works. Okay, so like this one, and like every point. So
I got one right. I got another one. I have space.
It's because when it blows out the folder, it's cold, and then when it shuts it off, it's normal. Okay. It is cold though while it's blowing because it's blowing directly on here. But I don't know why it's right. We'll go over it. Okay. But good guess. Well, I saw it. You were kind of maybe if I flip it. You were thinking through it. I mean, educated guess. But I still there you go. That's what I like. An educated guess rather than a blind guess. I do a lot of bad guesses. Well, the ABCD before, so she was getting excited, so it's blind a lot.
Wait, we didn't go to the last question.
Yeah, ABCD. So I have like getting rid of it. Okay, go ahead and bring it back up front. So I think it was 25. It said to go across the line y equal to x. And our starting point was 3/4.
Yeah.
So our correct answer when we flipped it is the point 4-3. So this is our answer. Number 25. Let's take a look at why that's the case. Here I've drawn in that line y equals x. And here's my point. 3/4, so over 3 up 4. I can see it's like a half diagonal away from the line, so I want to go a half diagonal in that same direction below it. So this would be the reflection. So notice what happens is that my x and y switch. And if we think about it, looking at our line of y equals x, my x is now y and my y is now x, which is why they end up switching. So when we're going across that line, we actually just switch the values completely.
And so after every time you flip it over the.
Yep, so every time you flip it across the line y equal to x, your x and y will end up just switching locations. You can think of it as drawing out that line, counting the distance away, or you have to switch the locations. This actually heads into something you'll be learning about next year, which is called inverse functions, which are functions that are reflected basically across that line y equal to x. The idea is that you switch x and y, so your domain and your range end up switching, and there's a lot more that goes with it. So this is kind of a precursor to that. So now number 26, set across the line y equal to negative x. And so that's our line over here. And they gave us the point negative 1, 3. So now you draw that in, negative 1, 3. Again, same idea. We are one diagonal away. I want to be one diagonal away again. So here's my reflection. And that is the point negative 3, 1. Now notice what happens here. My values switch, and you have the opposite signs that got negated. And if we think about our reflection line, y equals negative x, then y is now just the opposite of x. If I were to solve it for x is the opposite of y. So whatever x was is now your new y opposite. Whatever your y was is now your new x opposite. And again, that's going to be true anytime you're switching across or reflecting across line y equal to negative x. If you draw it out and just reflect across that way, or think of your rule, we switch it and negate it. The reason why this gets negated is because of that negative sign. Questions with that? So they could do this with any type of line. What you would want to do is just, again, kind of count that distance away from your line and reflect that on the other side. Okay. Do we have any remaining questions on our translations and reflections that we reviewed? Or something?
So this is what our quiz is on next class?
The next class is SWL review quiz. So for units 1 through 3, which your homework on the SWL review will be geared toward that. You could have transformations on it, but it's heavily on the SWL review. Okay, so last night you did translations, that's our shifting, and reflections, that's the flipping. Today we're going to be doing rotations. Actually, before we even go into that, let's just take a look at an example. So for some of you, you'll have a very easy time with this because you're good at visualizing what's happening. For the rest of us that aren't so good at visualizing what's happening, let's take a look at some ways you can go about doing rotations, and even more specifically, rules for rotations. So I'm just going to kind of walk you through a problem with rotation here, and then we'll talk about the actual rules for it. So let's suppose we start off at this point, year 1. Now some of you, if I were to say rotate this counterclockwise 90 degrees, which direction is counterclockwise?
This way.
Okay. So if I were to rotate this counterclockwise 90 degrees, this particular point would land in which quadrant?
The
4.
2. The second quadrant. This right here. We're going 90 degrees, so lands us in the second quadrant.
1, 2, 3, 4, right?
It's 1, 2,
down
3, and 4.
Was it?
Okay, so it's going to land us in the second quadrant. So for some of you, you're able to immediately know where that's going to go. Now some tricks for the rest of us is that some people are able just to turn their head and visualize it, turn your paper and visualize it. So there's some techniques. Something else that you can do is that you can think of this as this is the corner of a block, or this rectangle here. We're rotating about the origin unless they tell you otherwise. Almost always it's about the origin. So when this block rotates around the origin, or it falls over it, then we end up having, this is our new, okay. This is our new block. I'm going to have to reorient the board. with this being my rotated point. Okay, so think of that block falling over. Here's my new point.
I get it.
Let me rearrange the board real quick.
I get it.
That's way easier. Now, I wonder what you guys are trying to do. How to do it.
Okay. So for my rotation 90 degrees counterclockwise, my original point was 1, 4. What's this point now?
-4, 1.
Good. -4.
When?
Okay.
So just switch stops.
Yeah, so you can see that it switches, but then this guy became negative, right? That one still stayed positive. That
Is that
And if we think about it, since we're in the second quadrant, which values are negative in the second quadrant? X. So it should have a negative X value. Okay. Now let's go another 90 degrees. And let's go counterclockwise still. If I were to take this and go another 90 degrees, again, you can turn your head, rotate the paper, or if you think of this block still rotating once more, I have this rectangle here,
-4,
and this is my new
-1,
point.
-1.
Good, what's that point?
-1.
Good, -1, -4. And again, since we're in our third quadrant, we should expect both of them to be negative. So that's helpful for us there. How many degrees rotation is that from my very beginning? 180. 180. Good. All right. And then let's go
4, -1.
another 90 degrees. Okay, so I'm going to take this, and again, you can turn your head, I mean, a lot, or rotate your paper, or think of that block. It's rotated once more about that origin.
4, -1.
And then here's our spot there. And what would be that point?
4, -1.
Or -1. Now, would you agree that's the same as just going clockwise 90?
No.
Yeah.
Oh. I wasn't trying to trick you. So I could take my original go clockwise 90, or counterclockwise. How much would that be counterclockwise? 270. Okay. And then if I were to go another 90 degrees counterclockwise, it gets me back to my original.
Wait, how is...
So again, you can. Some of you guys are able to visualize it without doing these things. That's great. For those of us that can't do that, these are some techniques for it. Now let's talk about what happened for the points between here. This was my starting point. Not all of our points will be in the first quadrant, but we can at least see the pattern of what happens when we go from here all around. All right. So when I went 90 degrees counterclockwise, this was 90 degrees counterclockwise. What happened from my original point x, y? If I were to write out in terms of x and y, what would my new x, y be?
-1. No, negative.
You're right with -y. X, right? X was 1. It's now in the y location. Y was 4. It's -4. It's negative x. For negative y, x. Now, as Karak had said earlier, it's like they switched, and then the left side got negated. So keep that in mind. Right, so when I came down here, this was a total of, how much did you say degrees rotation? Okay, so this was a total of 180 degrees counterclockwise rotation. Okay, so from my original xy, what would my new point be now?
-X.
Good. Negative x, -y. So from the previous one, would you agree that we once again switched and negated the left side after we switched?
Yeah.
Switch, and then negate that left side. So far the pattern has been switch, negate the left, take the previous one, switch, negate the left.
Margaret, is it always going to start in the first quadrant?
No. Nope, we could start from the point of -4 and -5. But the pattern will still be the same of how much you, if I'm rotating 90 degrees counterclockwise, you will still have that pattern of switch, negate the left. Okay, so then when I came over here, how many degrees was this counterclockwise?
270.
So 270 degrees counterclockwise. From my original xy, what's my new point here?
Y to the X. Y.
Good. And so again, if we look just from the previous one, switch, and again negate the left side, that gets us there. Now if I were to go once more to here, would we agree that we switch and negate the left side and get us back to xy?
Whoa.
So you've got a few ways you can do this. Again, visualizing, rotating your paper, turning your head, using the blocks. or if you want to memorize these rules, you can memorize these rules. This is 90 degrees counterclockwise. We just go from here to that. You've got your point regardless of which quadrant you started in. If we go 180 degrees counterclockwise, we just go from there to this. Apply that rule, you've got your new point. 270 degrees counterclockwise. From here to here, that's your point. So you can remember each of those individual rules, or you can remember the pattern. From my starting point, if I'm just going 90 degrees counterclockwise, we get switch, negate the left. I want to go 180 degrees, do that again. Switch, negate the left again. I want to go 270, switch, negate the left again. I'm going to have you write this out once you get your paper, and in a way that I use to help me remember. You're welcome to use it as well.
Are they ever gonna ask you to rotate it at like around 90 degrees, like 115 or something like that?
No, the most crazy they could get is maybe do like a 45. So instead of 90, you would go kind of partially, but that would be a rough estimate of it.
Okay.
It wouldn't be like super exact. They like to stick to the 90 multiples.
Okay.
That's fine.
How do you, I don't get how, like, if you go, so since you went clockwise, I mean counterclockwise, it landed on, like, the top of it, over the line, and then when you went to the right.
I mean, like when the block turns?
Yeah, like, if you wanted to start out clockwise.
Yeah. So then this is going to be coming down. It's not going to swivel to be the bottom of it. When we rotate to the right, this as it turns, as it rotates down, this is now the bottom of the block. As we continue around, it rotates around again, it's now on the left side of the block. But it's on top of the block. So it's the same idea, it's just you're going in different rotation, different direction.
I just don't get how it got under it.
Then maybe for you it's better to remember the rules. You've got multiple ways you can go about this, guys. If you can visualize it, awesome. You can turn your paper, turn your head and get it, great. If you like the blocks, do that. If you like the rules, use the rules. The rules will never fail you as long as you have the right information. Okay, so this is the idea of where we're going with it, but let's go ahead and actually formally write this out. Now notice, I had you talking about this in terms of counterclockwise. We can write this in terms of clockwise. If I said 90 degrees clockwise, I would just simply go to this group here, right? So we can use either direction. We can use the pattern for either direction. You just need to know which direction you're going. Thank you.
This is an A.
Yes. I actually ate my snack.
Do you ever go to the
I
bar?
accidentally left my snack in the daycare bag. So it was my stash and there was one left.
Andrew.
Okay, let's start with to not get these notes. Okay, so what we were investigating is what we're going to write up here on the top. Now this is really, really important. Please write this at the very top of your paper. Unless otherwise noted. Oh, that too. Unless otherwise noted, go counterclockwise. Counterclockwise. So unless they tell you otherwise, go counterclockwise. So if it just says rotate at 90 degrees, that means 90 degrees counterclockwise. Unless otherwise noted, go counterclockwise. You'll see me use CCW to represent counterclockwise. Guess what CW represents? Clockwise. Okay. So for example, where it says rotate the image 90 degrees, about the 15th, that's 90 degrees counterclockwise. Now sometimes, instead of telling you a different direction, they do, flip your paper over, rotate negative 90 degrees. So if our normal direction is counterclockwise, what do you think negative 90 means? This is the same thing as clockwise 90 degrees. Okay? Okay, so they will either specifically say clockwise, or they'll use the little negative sign to indicate that you're to go opposite of clockwise. I believe the reason why our standard is counterclockwise is because when you get to pre-calc and you learn about the unit circle, which deals with their 0 to 360 degrees, we go counterclockwise around. So I believe that's why they do that. Yes, Jane?
For the first one, it would be so much easier to do clockwise because it's basically.
I know.
So I think they just switched it to go.
It's just the way it was. Next year, I know to shift it. But it is what we have today. Okay. So our rules for rotation, that's what we were investigating before. Now notice these are written in terms of clockwise. Let's go ahead and just write above it, what's the counterclockwise equivalent? So if it's clockwise 90, that's counterclockwise how much?
Negative.
Negative 90 or
270 here.
so then clockwise 180 is how much counterclockwise?
180. Yeah, that one doesn't change.
And then clockwise 270, same thing as counterclockwise. Okay. Now we're going to write out what the new rule is for each of these. So let's see. Let's start off with our counterclockwise 90, since that was the first thing we did. Our original point xy, we went counterclockwise 90, became negative yx. That is our rule. Negative yx. This becomes negative yx. When we went counterclockwise 90. When we went counterclockwise 180, our new point was negative x, negative y. So our new point is negative x, negative y. We talked about how that makes sense because it's going to go in the kind of diagonal quadrant, which the sides would be opposites. All right, and then we went counterclockwise 270. Our new rule was y, negative x. So if you struggle with the visualizing or the blocks, you can go ahead and memorize these rules. Now personally, back when I first learned this, it was hard for me to kind of keep it straight, so I put it in the format of a coordinate plane. Now keep in mind, our point doesn't always start off in the first quadrant. So when I say that we're starting here, this is just simply to help me visualize knowing how much 90 degrees or 180 is. It doesn't necessarily mean that I'm always starting in the first quadrant. I just use this to help me keep in mind this rotation. Okay, so we start off with xy. Now, when we went 90 degrees counterclockwise, remember the pattern that we talked about is that it's switched and negated the left side. So we switched and then negated that left side. And if I want to go another 90 degrees counterclockwise, take that previous point, switch, and negate the left side. And if I want to go another 90 degrees, take the previous point, switch, and, okay, so I switched them, and I want to negate the left side, so it's actually a positive.
Why did the other,
This is just a rule that we did before. So all I'm doing is I'm taking these rules and just put into this diagram here. So counterclockwise 90 degrees, here's my rule, exact same thing. 180 degrees, here's my rule, exact same thing as here. For me, visually, I have an easier time remembering it if I visualize it like this. So then what this lets me know is, if you say, all right, take this point, and I want you to go 270 degrees clockwise. I'm starting here, 270 degrees clockwise, 90, 180, 270. This is the rule I use. Okay, so this just lets me, personally, this helps me visually a lot better than writing it like this. You can use it, so you don't have to, it's totally up to you. So I remember it like this, and I just remember that pattern to fill it in. And then I always refer back to this when I do my rotations. Questions with that? So my starting point for my rules is right here. That doesn't mean I'm in the first quadrant, it just means that's my starting point for my rules, and then I know which rule to choose based upon what the instructions are. Okay, I feel like my smartboard is getting unoriented again, so I might have to fix it. But let's go ahead and take a look at this problem here. Triangle RST. Alright, so it says it has vertices 0, 3, 4, 0, and 0, 0. Find the coordinates after a 90 degrees clockwise rotation. Okay. So 90 degree clockwise rotation, you can go ahead and draw your triangle. So we have 0, 0 is T, R is 0, 3, and S is 4, 0. So here's my starting triangle. For those of you that are able to visualize this and just take the whole triangle and rotate it 90 degrees clockwise, you can go ahead and draw it out. And for this one, it's not too bad because we do have it's that right triangle. It plays pretty nicely on your graph. But if you struggle with that and you want to use the rule, it says 90 degrees clockwise. So I'm just going to go back up to my image here. 90 degree clockwise would be this one here. So this is the rule that I'm going to use. It becomes y negative x. So I have xy becomes y negative x. And then you can just apply that rule to each of your points. When I go to do r prime, again, my y is now my new x value. And my x, I put in there, I have negative 0, which is just 0. And s prime, and I'm going to switch, and then that's x. Have 0, negative 4. And then t prime, is it very exciting, still becomes 0, 0. So if you prefer to use the rule, you're welcome to use the rule. If you prefer to visually just do it, you can do it that way. So I'm going to go ahead and draw it out. Make sure it says find the coordinates. Make sure you actually list the coordinates for your answer in the end, as well as have that drawing. So I'm going to go ahead and draw it. And notice because this is my image, my pre-image is the original letters, my image has the primes. Make sure you have the primes. The image is your final picture. And then S prime is 0, negative 4. And T is 0, 0. So we should get this. I don't care which method you use. Just find one that works well for you and be consistent. Questions with this one? Okay. A couple of things with this. When you go back to double check that you have the correct answer, make sure that your shape is congruent. We have a triangle, so you should finish with a triangle. It's a right triangle. Your answer should be a right triangle. Segment RT is 3 blocks. Segment R prime T prime should be 3 blocks. TS is 4 blocks. T prime S prime should be 4 blocks. RS is my hypotenuse. R prime S prime should be my hypotenuse. So just do that little quick check to make sure you were doing it correct. Any questions with that? I want you guys to go and try this one. Triangle FGH. You can do it visually. You can do it using the rules, whichever you prefer. Oh, I'm sorry, I gotta get back to it.
What's so weird? Yeah, I'm not too much.
This is the information. Make sure you write out your coordinate points. You go and just check with your shoulder partner once you've gotten them.
This paragraph.
Yeah, go back and get the.
Did anyone, when you picked up your SWL packet, was it missing the front page? If everyone would check their SWL packet.
I'm missing.
So everyone on your SWL packet, the very front page looked like this. Everyone to make sure our SWL packet is correct.
When you rotate it, you reflect it.
Is yours on the front page? Good. Let's see first this front page.
Wait, what's the
Is yours on the front page? Get it out, I can see.
I know that.
You have to rotate it.
It's because it's so.
For the time, I got that experience, like, maybe you learn once, and then you're getting
It only goes 1 hour.
I also got. I also love those like way later.
community, very nice.
What did you do with that? Yeah. Thank you, Dominic. So we're gonna go -3s, that's what so our we're gonna use this useful indicator. We have to go to the left side. We leave it over here, so we can. So we're gonna do this, so we'll take your original. So we can, let's go right after.
No one else? I guess we lost.
Yeah, I'll think that's right.
So now our reality is -1, 2. So now y, now becomes negative and goes next.
Well, because like our y was already in this axis.
What is our x?
So they're gonna
X.
All planets, you know.
Oh, just says x is
Why does it sound like?
each one.
You're the same, yeah.
Alright guys, I'm going to go ahead and display our answer for triangle FGH. So our rule, it says 90-degree rotation, then specify, which means we're going to be going counterclockwise. Counterclockwise. So we look back up at our rules. Counterclockwise means it's this rule that we'll be using. So -y, x. Becomes -y, x. Alright, so my f prime is going to be -2, -1. G prime is easy, 0, 0. And H prime is +1, 3. Do we agree with these points?
Yes.
So since the G is the same, how would you label that point?
You're just right next to it, G prime.
Okay.
He did those eight.
H. So again, the rule is -yx. So I took my H as y, which was -1, and I want to put that here, but it's opposite of it. So the negative, the opposite of -1 would be positive. That's what goes in my x location. And then my x value, which was 3, goes to the y location.
Which further, wasn't it colored when you were?
Wasn't it what?
Were you not actually touching on it?
No, I was touching on it. It's the smartboard, even though I oriented it, is wonky up here. but I don't know. It struggles. Okay, so our final image would look something like this. And I get to one. This is my F prime. Here's G prime, and H prime would be 1, 3. That's our image, our final piece. Okay, questions with that? Alright, so our next component here, I like this one because it takes us off the coordinate plane. It just presents it a little differently. So since point R is the center of our quadrilateral, which is a good one, find the image of the point or segment for the given rotation. So 90 degrees of rotation of H about R. So we're rotating about the point R. So you can think of this as your origin, is what we're rotating about. So H rotates 90 degrees. What is it now going to be? That's the point that you're going to write down. Okay, good. So you're going to go through and do that for each one, whether it's a point or the segment, write out what the new one is going to be. All right, 180-degree rotation of M about R. What is that? Also T. Good. I'll set it on the plug. All right, and then our next one, 270-degree rotation of AT. What does that mean? HT. HT. Good. So if it's 270 degrees, that's counterclockwise. What is the same for clockwise? 90. Good. And then our last one, 360 degrees. That's an easy one. HM. Good. It's the same thing. So 360 degrees just gives us back curve. Okay. While we wait for that to come back up, do we have questions with that? Okay. Real quick, let's just revisit the top there. I know we skipped over those very first two problems because I want to practice using the rules. Here we go. Okay, so our answers were
T, HT, HM.
Before we move up to the top, do you have any questions on this?
No.
Is the background homework?
Okay, so AT,
Every class.
and it says 270 degrees. So we're going counterclockwise. So we have to go 95. Guys, stop talking. I'm not sure why there's talking happening. So we go 90, 180, 270, and that takes us to H. Does that make sense? Okay, so back up to the top here. Yes.
Is the background homework?
No. So on the top here, we have that it doesn't give us a coordinate plane once again, but it's asking us to rotate about the point P. So P is basically like our origin. To help you out, you could kind of just draw in a fake coordinate axis if you like.
Oh, that's so
So then we're rotating at 90 degrees. So 90 degrees counterclockwise. Notice that it goes between B and C, so we should still. Oh, I need more space. So I should have a little more space. There should still be that gap, so I'm just going to that gap. Here's my B, here's my C. And again, if it rotates 90 degrees, you guys can be down here. A, B, C. There should be A prime, B prime, and C prime. Okay. So if it helps you to go ahead and kind of draw a fake coordinate axis, you can, but that's cool. Okay, go flip it over to the back side. Alright, I want you to go ahead and complete these with your shoulder partner. I know some of you guys I grouped up into groups of 3, so whoever I grouped you up with before, I'm going to complete the back side. Take about 5 minutes and we'll go over Guys, if I could have your attention, just to give you a little bit of hope with this, my recommendation is as you're drawing your picture, so let's say that you first rotate this point here. So let's see, that would become 1, 2, 3, 4. 1, 2, 3. You can either use the rules or you can do it visually. But as you go to do this next one, once you have that, notice this is a length of 3. I can just go length of 3. And I've got that side there. Connect it as you go so you can see your shape being formed. Because if you start to do your shape and then something wonky goes like this, you know that you messed up something, right? So if you draw it as you go, you can make sure you're actually drawing the proper lines rather than in the end, be like, when you go to connect it, not sure what you did wrong. So draw it, connect it as you go.
This one isn't.
Yeah, let me.
I may, why don't you do that?
No, like right here. I like this one. This one's a pretty solid.
I like that one too. There's no point for you to, when you rotate.
If it was an actual problem, I would probably take the center meters look at it. I read it in the last. Let's see. So we want basically what we should have is that this is what we should next. So the fact that it's really smart. So I'm going to just shift it down. So let's see what that does. So we have 90 degrees on.
Oh, this one you said.
I really like this first. Yes. So, so what do you expect now?
Notice they put
Take my Wi-Fi. That was. Does that make sense? Not necessarily that you're on right now, it's just, stop that. Everybody see your right there.
No, I'm.
Try this guy here. It's only 45 degrees, it's not a whole 90. Ooh, I like it, except you went the wrong direction. It's negative 45, so we're going to be going 45. Similar to that. No?
How do you do that? This one, here.
So they've actually mainly drawn it, this is 45 degrees there. So you're going to have to do it in a practice. Michelle Brenner, arrow. Okay, that last one, the rotation. She must be one of those visualizing people. Those lucky ducks. Hey, so what we should expect is that the shape of the entries. So it looks like it just got flipped across and then actually rotated. Oh, sorry. So 270 would be counterclockwise. So it would, we would still be, it's the same thing as 90 degrees clockwise. So did you use the rules or did you use visualizing? Okay, so let's go ahead and pick a point. I'll help you walk through that. Guys, I'm going to go ahead and show you the answers for those. See how you did with it. Here are those first four. So this block. So now,
Oh, yeah,
this
it's
way, this way. There you go. There you go.
Yeah, I just like
Good.
it. I just like it.
Just a second. Okay, so our first one, same idea as clockwise 90. So again, this horizontal line here should become this vertical line here. As you plot points, when it's that nice horizontal vertical, you can just count those blocks. The diagonal a little more work. Our trapezoid here, 450 degrees, that's just the same thing as a full revolution and then 90 degrees after that. So it's the same thing as just 90 degrees counterclockwise. And again, as you connect points, once you have part of your base, you can just count that distance and you know that that's horizontal, it should become vertical for the 90. Okay, let me go ahead and show you those last two.
Can you post this on Blackboard?
So our last two, 360 degrees, just puts you right back in your same location. So it's the same thing. Now our 45 degrees is a little bit of work here. So 45 degrees, but it was negative, so that means going clockwise 45. So my horizontal should now be at that nice 45 degree angle diagonal. And my, what was the diagonal is actually now on our axis. So the diagonal goes to vertical and the horizontal goes to diagonal. Your homework tonight is rotation worksheet, which we're about to give you. And don't forget, you've got a little bit of Main Madness and a few S12 rounds.
What's the Main Madness?
That's what the degree picks up. That's Main Madness at the top. Asks about just 2 months. Don't worry. Send one more back.
You got it in like
No,
what?
you might just want to put this sense.
Under the, well, yeah.
Yeah, thank you.
It's on
Main
the
Madness.
And copy.
No, that's for no, you'll be able to do something.
The SL Main Madness. Remember guys, Main Madness and SL, you don't have to do the whole thing, just the problems that are listed. Next class we'll have our SL review quiz numero 1. Uno.